Welcome to this Panda demo. I'm going to start a new project now. So when we click Start New Project, we see the designer open, and the designer is a very simple designer whose purpose is for you to input the massing of your structure. Typically, just choosing the right decking can save perhaps 25% of the carbon and perhaps 15% of the cost, give or take. Of course, if you then adapt the layout a little bit, the gains can be as high as 50% of the carbon and 20% of the cost of a frame. Then we go into Panda proper. You click Run. And you see that Panda has determined that there were, in principle, nearly 3,000 options, and is going to run through every one of them. And of course, a number of them are not possible, and so they will be discarded. And you can see them being displayed here. This is the ABCDE is the iStruct scale, as recommended by the iStruct, and you have the cost and the carbon, and you can see these things being displayed here. Whilst it's running, I'm just going to show you a few things that you can consider. Panda is not a black box. All the values are there for you to see and modify as appropriate. First, the LCA, concrete, steel, timber, and the rest of the carbon components, including the various distances. These are default recommended distances, but of course, you should adapt them to your specific site. And this, and you can see all the values, and they can be recalculated, and you can set as a default. If you have typical values your company uses, you can create a new default, and it will open automatically. The costs are also not, they're also not a black box. You can see all the values that go in, all the rates, and you can know how the cost was calculated. This, of course, should be adapted with your QS and have a discussion what is the best value. Panda is not a black box. It's not just the cost and carbon values which are clear, but it is also, if I click on any one of these solutions, let me move this a little bit, we can see that's my layout, and I can see including the elevation, and I can click on every one of these bays, and I can ask for an engineering report. And the engineering report will give you all the engineering tests for all the beams and columns and decking that governed this specific selection. And that way you can look at the design, and this is meant to help you when you move on to the final design. This is meant to help you get a better result. You can see here the cost and the carbon breakdown, also by materials and operations, and this can help you also know what are the pain points for your structure. Because it is not sensible to output that many options and present them to the client, you need to be able to filter them down, and there's a whole options here to do the filtering, the carbon, the cost. Mass here is important because maybe you're not designing a building, you're in fact designing a vertical extension, and therefore it is total mass that needs to be limited. You can verify that your building is within best cost and best carbon, and you can then filter by all sorts of things such as the deck system, the number of stories, whether there are transfers, and so on and so forth. Finally, you can explore design option and design drivers. So this was my baseline set, which I'm just going to let it finish before I save it, but I could save it at any point. And having done that, I can then compare and see what happens if I change my my design option, my design requirement. So this was my option. And we can also, of course, use the visualization to understand what is driving cost and carbon in those options. Column spacing is a very common driver. Of course, larger spans imply more carbon. And we know that, of course, as engineers, but it's useful to be able to put a number on it. And we can see here that going from very small spans has the benefit that it allows you for those softwood joist structures here. So that's one of the reasons you might want to have the smaller spans. But for example, steel or concrete structure, the effect is not as large. However, going to much larger 9-12 meter spans has a big impact in cost and carbon. For example, you could have a sense of the structural zone depth, which is typically an important consideration. How much scope do you have for vertical optimization? I'm going to save this set as my baseline. And for example, we can look at what the effect is of picking, for example, another LCA cycle. And here, if I compute, what you'll see is it keeps the previous one, and we can see the new results appearing as we're running. And we can see this shift on the left, of course, because module D is now allowing for recovering some of the carbon. And let me go back to frame so we have a sense of what's going on. The purpose of Panda is not to automate the job of an engineer. That's not something it can do or could do. The purpose of Panda is to help the engineer at the early stages of the project be effective, to know what the overall scope of options is, what is possible, and to make the best informed decision very early on when they have the maximum impact and can provide the maximum benefit both in terms of costs and in terms of carbon.